In the previous episode, we added WireGuard to the Devlab router using the concepts of infrastructure as code. In this episode, we will add static firewall rules using the same method. We will define the rules in a YAML variable file and deploy them to the router using Ansible and get firewall rules defined on the router. Our router is not an industry standard production box yet, but we are making progress. With our work today, we will prepare the router to move from inside the network to the edge. And with some security that we will add later, our router will be ready to face the internet. Currently, we have a main network and a Devlab network. The router's role is to pass packets and connections from the Devlab network to the main network, which is what we can do right now. In the context of the Devlab router, the LAN is the Devlab network and the WAN is the main network. We added DNS, DHCP, and dynamic DNS in previous episode in the LAN network, in the Devlab network. And last week, we allowed some hosts from the WAN, which is the main network, to use a WireGuard tunnel to access hosts that are inside the LAN network. For our current project, we want to add some security to the router. For example, we want to make sure that no unauthorized connections from the WAN to the LAN are possible. We also want to be able to block some LAN hosts from accessing the internet. Those could include IoT devices that do not need the internet, Windows spy machines, printers or office equipments, or anything similar, any devices that we need to block from accessing the internet, and it lives inside the Devlab network. Besides, WireGuard is very secure if set up correctly, but it is not easy to set up WireGuard on the clients. We have automated tools to set up WireGuard on the router, but on the clients, we still do not have that. And it's not easy. So we might need an easier way to access some internal hosts until we set up WireGuard on all our hosts. For this, we might use port forwarding. As with WireGuard, our tools are nftables and Ansible. We will use the same router role that we built earlier and expand the nftables rules that we have already created to do the routing. We will expand them to cover our desired use cases. The Devlab router is an IPv4 device as of now, but we are very close to opening it to the internet and we can start planning for IPv6. This requires many additional protocols and many additional protocol changes. This is, in fact, a fundamental change because of the design we have built so far on IPv4. But we will start to change that now. And today we will incorporate many features that are useful only in the IPv6 context. So let's see how we set up port forwarding and we accept incoming connections the infrastructure and code way. This is the Linux router variable file, and it has configuration that we have seen earlier, for example, for the Kia and for DNS. And here I added some Linux router variables. I start by defining the interfaces, then the subnet, then whether I want to pass pings, so ICMP echo requests. And if we set this to true, we will be accepting pings and responding to pings. If we set it to false, all ping traffic will be dropped. Then we set up open ports on the router. And here we have two open ports. We have port 22 that is open for SSH and it accepts connections only from this subnet, which is the main subnet. And on the UDP protocol, we have the WireGuard port. Notice here that I have only from, here I don't have it. And here I have only from with a subnet. Here later on I have only from with an IP, and all these will work with us. In addition to IPv6, and I'll show you how we are managing that. Then we have port forwarding, and we assume that we might need to block some hosts. So we have this host, for example, cannot have access to the internet. These are just examples. What you want to do with your router, which ports you want to open, which hosts you want to forward the ports on the router to. This depends on your setup. these are just examples of what you can do. All this configuration will be used in a template, and this is the template. It looks complex here, and we will go through it like section by section, but basically this is the almost the same template that we had previously. We had an input chain, a forward chain, and an output chain. And we had two NAT chains, the pre-routing and post-routing. We will be renaming some of these and merging these here together. So let's see it. We start by flushing the rule set. We define some in our interfaces, and these come from the interfaces that we define in the variable file. The subnet, the LAN subnet, I think we can remove. Is it used still? It is not used, so we can safely remove it, and we remove it also from the variable file because I don't need it. We start by table inet. We use inet here instead of IB or IB6 because I want to have rules for both protocols, for IPv4 and IPv6. The challenge for combining the rules is with the protocols, and you will see, for example, sometimes we use ICMP, and sometimes we use ICMP-v6, the protocol. But the main challenge is when we are comparing and filtering based on the header of the packet. For example, the IP address, the source address, is in the header of the packet. Before I supply the header of the packet, I'm saying whether this is an IB or IB6. We pass it to the filter that tells us if this is an IPv4. Otherwise, we write IPv6. So this way we will be able to simplify the resulting rule. And we start not from here. I put these here, the inbound, because normally when you are troubleshooting, this is the first thing you want to see. The custom rules for inbound, but the processing basically starts here. So chain inbound. First, we have this chain, which is of type filter and the hook input. So this is our input chain. Any packet that will enter the route will enter from this chain. First, we drop a new connection that does not start with SYN. And this is to block some types of abuse on or the distributed denial of service on the router. If we accept ping, we output some rules to allow ping requests, the echo request. Then we allow established and related traffic. We drop invalid traffic. Anything we need to drop, we do it after we put all the rules that have limits. Then we allow ICMP packets that are needed for IPv6. If the traffic is coming to our local host, we accept it. If the traffic is coming from the WAN interface, we go to the WAN interface chain, which is up. If the traffic is coming from the LAN interface, we go to the LAN interface chain, which is above, and we will go through them one by one. And anything else, anything that passes here, we drop it. So we don't have a default policy here because I like to count packets. I like to see what packets are dropped. Here we see the chain for the input. We see if we have accept incoming, if we have anything configured for accept incoming, we have a simple loop on the accept incoming, and we write the NF table rule. The NF table rule is it looks complex, but I will show you the output, the resulting rule. I think I can show it. So now I am on the router, and this is the resulting rule. So first we have allow connections from known hosts. This is the first rule, and we have the first rule IP address, this here, and this is coming from the variable file from this rule here. So this configuration in the YAML file is mapped in the template to generate this configuration for the router, and this configuration for the router will generate like almost identical NF tables configurations. The next thing is we want to allow port forwarding, and to forward a port we need to open that port in the on the router so that we can accept connections. Here we open the port, but later on in the forward we will do the real port forwarding, but here we open the port for connections. And this will be the resulting rule. Basically, this is just template substitution. The complex part in these rules is when we want to check whether we have IPv4 or IPv6. And the rule looks complex like that because I decided to merge IPv4 and IPv6 in the same way and allow writing IPv4 and IPv6 subnets and IPs here, because I think that will be easier for maintenance on the long term. You don't care about whether it is IPv4 and IPv6. Ansible will take care of that. This is the only thing we need to open for the public. The ports that are explicitly open and the ports that open because they are used in port forwarding. Nothing else is open for the outside. And this basically with the drop here will close the router to anything that is coming, any connection that is coming from the outside. For the LAN, we accept only TCP on port 22, which is SSH, and on port 53, which is DNS. On UDP, we accept ports 53 and 67, which are DNS and DHCP. And any connection coming from the LAN network to the router will be dropped if it is not like on these ports. So even from the LAN networks, you cannot connect the WireGuard port. The connection will be dropped here. I think this secures the WireGuard router to a degree. It's not like full security because you can still do some harm if you know your way. And that's why I am not confident until now to put this router or to advise you to put a similar router facing the internet. We still need to do some defenses on the router, and I'll talk about that later. Then we come to the routing part. We start with the forward part, and we said we will block some hosts from accessing the internet. These hosts are connecting to the router as a router to forward. They are sending forward packets. They do not come to the input chain, they come to the forward chain. And here we see if the source interface is in that list, we drop the packet. We count these packets and we drop them. Any host that we put in this list here will be blocked from accessing the internet. Then if the interface is LAN, anything other than this, we accept. Now we come to the NAT board, the network address translation rules. And in network address translation, we have first, we want to do DNAT to the port forwarding. So we set up port forwarding here, similar to this. So we started port forwarding here, and this is the rest of the port forwarding. If the input interface is the one and it is targeted to this port, we do DNAT to this IP here and this port. Post routing is the same rule that we have used before. This is almost exactly the same rule. I only changed the output interface name, and I think I should put interface name here. We put interface name because this is safer when restarting. It does not require the interface itself. This is a test on the name of the interface, whether it exists or not. And in the output chain, we do not allow any invalid packet to leave the router. This is also for security in case the router is compromised or in case anything that was able to pass through our protection, we prevent it from going out to the local network. So basically, this is all the configuration that we need for the router. It looks complex here, but once we see it in this way here, it is pretty easy to understand. And notice that all these configurations were generated from the variable file. I think that's nice. I was very excited when I was able to do this for the first time. I hope you will like it. The end result after running the Ansible role and applying all that would be something like this. This is the configuration. The command I used here is this command here, clear and nft list rule set. We still have the WireGuard rules because WireGuard is enabled. So these are all the configurations that we created for the router, and all these configurations, we generated them from the variable file using infrastructure as code, concepts, and ideas. We defined the end state. So this is what our router will do. And we have Ansible that generates all that for us. Now we need to test it. Port forwarding is working because I can access the Devlab from outside. Now this is the host that I configured to connect to the internal host on this IP, and it works, and I tested from a different IP and I cannot access this endpoint here. Now if I connect to WireGuard again, now I can access the same host using the internal IP, so .100.99. So now let's see 121, this guy here, console, and let's try pinging the main router. Nothing, because this was explicitly blocked and all the packets are dropped. And if we verify here, see here, we have blocked 19 packets. If I do it again, now we have blocked 64 packets. So packets that are coming from this host are being blocked, which is what we want to see. Try to do the same, and now from this host I can ping the firewall, the main firewall, which means our setup works. Now I have to say that I am not a networking expert. I am a developer. I have said that multiple times and I keep saying it. And I would love to have a professional firewall expert look at the rules that we generate and look at the entire concept and advise me and advise the audience if there is anything that needs to change, or if there is anything that we need to consider before putting this on the internet. I know that we need to do some proactive and reactive security measures. For proactive security, I'm thinking about deep packet inspection. And for deep packet inspection, I'm considering a tool called NDPI. So maybe we will have the next episode about proactive security. For reactive security, the best tool that I know of is fail2ban. This has been tested in so many domains, and I trust that tool. And it is very flexible. So maybe for reactive security, for checking after the fact, not before the fact, maybe we will use fail2ban. In addition to that, before we can put the router on the internet, we need to think about defense in depth. It's good to secure the perimeter, but we need to secure what is inside the perimeter as well. Here I'm thinking about the internal services in the network as well as the services on the router. So secure SSH on the router itself, secure SSH on the internal network. This type of actions also requires some thinking before we put this router on the internet facing the public internet. We are making progress on that front, but we are still not there yet. So as we said, we need to work on the security of the router more so that we can put it facing the internet. And in the next episode, I'll be thinking about defense on the router. I have some ideas, but I still did not start experimenting with them. Next, we will think about the IPv6 network. As you know, whenever a host gets a public IPv6 IP, it's on the internet. There is nothing behind it on the internet. There is no netbox. There is no network address translation for IPv6, so it is accessible and anybody in the internet can access that port. So we need to do some serious security and considerations before we put our hosts on the IPv6 network. I am producing AI content and my AI videos are getting good feedback, especially for a new channel like mine. My AI content is directed to developers. My last video was about how to use AI image generation using a very old laptop. like an old laptop 7-8 years ago. And you can do that, and you can even do some post-processing. For that, you need to check my video. Regarding season 2, when I started this series, I thought that we will do season 2 on VMware ESXi. However, they pulled the free version of ESXi, so my direction now is to go with OKD. I have good experience with OpenShift, and I think I can explain and OKD, and I can do whatever I want on an OpenShift cluster. However, I recently got an idea to do the second season on a vanilla operating system using Ansible, because there is nothing like that. There are no administration tools or infrastructure as code tools for running hypervisor on a vanilla operating system. That's an interesting idea, but I want to do Helm on OKD in the next season. But I am open for suggestions. Also, if you are a professional firewall expert or a professional security expert, please have a look at the security of the Devlab router and let's know what you think in the description below, in the comments below. I want to thank all the people who follow me on YouTube, GitHub, and Medium, especially on Medium. Because I started getting more attention there, and my articles are getting published in a publication. The article that accompany this series are published on a professional DevOps publication on Medium. I also would like to thank all the people who leave me comments and who interact with me in any way. Those interactions with the audience give me the feeling that my videos or whatever I am doing has some value to somebody else, which drives me to do a better job. If you think that my videos or the code that I am writing in this series provide any value to you, please let me know in the best way for you. As usual, the code for this episode and for all the previous episodes will be on GitHub. And the link to the repository will be always in the article and in the description below the video. There will always be an open pull request in the repository on GitHub, and the code I am writing for this episode will not be merged until a new pull request is submitted to the repository. So if you open the repository and you look for the code, you will see it in the pull request. You will not see it as merged in master until a new pull request is submitted. Then I will merge it. If you have watched the video, maybe you will enjoy looking at the code and telling us what you think. I welcome comments, code reviews, and any type of feedback on the code in GitHub. The repository is under the MIT license, so you can do with it whatever you want. Please feel free to fork the repository and modify it to match your own Devlab. And if you like, you feel free to send us pull requests. You might be interested in the previous episodes where we built the DNS and DHCP and dynamic DNS on the Devlab router. And also in episode 3 where we designed the entire routing, the entire network that we have been using until episode 20. You might also like my AI playlist where we have a comparison between large language models. Please follow my work and let's meet in a previous episode or in the next episode.